Welcome everyone to the engineering courses series we offer, and this particular course is on digital signal processing. As in the past, if you have seen or attended our lectures, we do emphasize students that if they are interested in find the details on the historical journey of the words, like in this case, digital signal and process or processing, uh, we encourage you to visit a quality source like Cambridge or Britannica website in order to acquire that information, because that's a topic in its own, and it's very interesting information one can extract by practicing this process. Okay, so let's carry on. So we offer these courses under Contact Field Institute, which is an affiliated organization with Soft Galaxy Technologies Inc. And this is our LinkedIn profile. Anyone interested, encouraging to connect with us through that link. Any questions you have, you can see that what we have done in the past and what services we offer. Another way to connect with us is by sending an email to info@hs for humanity serving clouds.org, or softgalaxy.hsclouds@gmail.com. One of the key things we firmly believe in is this particular sentence, that there is no shortcut to glory. It means that you have to practice the basics, acquire the amount of skills required to do a particular job at hand, and be able to be successful in a particular field of your choice. So that's why the word that there is no, or the sentence that there is no shortcut to glory. So what are the career and course objectives? Basically to establish firm understanding, acquiring the analog signal and processing it to the digital world, and processing the acquired signal to extract information for desired purposes. So this is what you will learn in this particular course. So when we talk about digital signal processing, it's a one-dimensional signal. What we are talking about, we are not talking about digital image processing. So just be very clear on it, that this digital signal processing, in this particular course, we will not be discussing digital image or video processing. We do offer another course. Please check our playlist or connect with us and to get that core information. And that particular course can put you on the path of to become a firmware developer, firmware developer or embedded developer, embedded programmer, or architect. What it means that you can program a microcontroller, microprocessor, DSP. So these kind of jobs you can perform by taking this particular course path. Yeah, obviously you can do GUI development as well, because that's the kind of tools we'll be using, which will help you acquire these particular skills. We have discussed in our introductory courses some of the basic courses, visiting these YouTube videos, which we highly encourage the students, if you have not seen our prior lectures or videos, to download these slides. In the description below you will find the link. Download the slide, visit every link you see here, because it gives you the information you will acquire, you will learn in this particular course, how that information is utilized in the industry. Like in cell phone case, it's an analog signal, get it processed to receive the required information. This is basically a factory tour showing you, numerous ways this particular acquired knowledge is utilized in the cell phone manufacturing business, or in robotics, or in self-driving cars, or an Amazon fulfillment center like location which uses robots and drones, along with so many other technologies in fulfilling customer orders. Okay, so we will be using MATLAB. Heavy emphasis on we will be using MATLAB or Python during this particular course, but primarily MATLAB. But we do encourage students to have these resources like Python or Multisim as well available on their site or be available to them. LabVIEW Community Edition is also good to have. Depending on what tools are available on your site, we will assign you relevant assignments or lab work, which will help you acquire industrial skills, help you market in your career objectives. Okay. So this is I'm sorry, this is a mistake. Let me correct it. So this is the standard distribution of marks in this particular course. Assignments, which is 10%, includes the labs we will assign to you. That will be part of assignments. So in this particular discipline, 5% of the assignments will be given to you before the midterm, 5% before the finals exam. The lab work will be an exam which worth 20%. It's a 1 hour exam on the day of midterm, so before the midterm, and on the day of final, before the finals. And in between, you will be given a half an hour, 1 hour break before you will be given the midterm, which is a 1 hour long exam, and the final, which is hour and a half long exam. We will be doing industrial tours in order to, give you kind of a practical knowledge on how the learned information in this particular course is utilized in the industry, which will basically complete the learning circle. Okay. Okay, so when we talk about digital signal processing, this is a very, simple diagram, basically conveying that what is our purpose. So like in this case, a human is speaking in a microphone. So microphone has a sensor, and that particular sensor's only job is to convert the air disturbances occurring because of a human speaking and convert it into an analog signal. Okay, and that analog signal or electrical signal gets amplified, and the amplified version gets into an ADC, and ADC stands for analog to digital converter, and at the output it basically spits digital data, and that digital data gets processed, stored by a digital system like computer, laptop, you name it, and so this is basically completes the data acquisition path of a digital signal. Okay, so another path is that this computer or a smart system or a device can generate digital data by itself, okay, by itself, not depending on someone speaking. It can generate that digital data by itself or play back the data acquired previously to a DAC. A DAC stands for digital to analog converter. Okay, so it takes in the digital information, converts into analog signals, and those analog signals can appear as sound through a speaker. Why? Because the electrical signal, that amplified analog signal, performs required energy vibrations for the diaphragm, which basically vibrates, and because of that speaker, which has basically the diaphragm, because of those vibrations, there are fluctuations, disturbances of the air similar to the voice acquired previously, and that's how the amplified voice is comes to our ears, and we perceive that as amplified signal. Again, so this is basically the path we will be discussing in this particular course, that how we acquire a signal. It can be a human voice, it can be something else, and how we send the signal towards this analog path as well. So just as an example, so this human speaking, the voltage V in, the input voltage can be, like a fluctuation like this with respect to time. On the x-axis, it gets converted to numbers depending on the resolution of this ADC. In this case, it's 8-bit resolution, but anyhow, so it gets converted into bits, and on that path, those same bits are taken by a DAC, which converts into an analog signal like this. As you can see, it's pretty choppy. So normally we do not send a signal like this to the output directly, because there will be a lot of noise. We filter and further smooth this signal to appear something like similar to this before it goes to the speaker. Okay. That's another very good block diagram of a digital signal processing system. And as you can see here, that we have a sensor, sensed and amplified signal. Most of the time, after sensor, there's an amplification, because the sensed signal doesn't have enough power, for that filtering purposes. So the sensed and amplified signal goes into, it can be a low pass filter, or it can be a high pass filter, or it can be a band pass filter, depending on what type of an application we are dealing with. And when we talk about filtering, we talk about anti-aliasing, filter as well. We will discuss what it means in this particular course. The signal gets into an ADC, and we discussed in our previous slides the analog signal converting into digital data, and that digital signal processor receives that data, processes it for whatever desired objectives, and before sending it to that another ADC. That to me is, I don't know why they are using another ADC. That doesn't make sense. Most likely this is DAC, so it's a typo, I'll say. That makes sense, because the information is already processed here by the DSP. Okay, so that the processed data in the digital forms comes to a DAC, which is a digital to analog converter, as we have seen in our previous slide. And that analog signal definitely gets into a filter like this to remove edges, to make it something similar, very close to look like an analog signal, before we process it, maybe to for the actuator, or for any other purposes. In the previous slide, we were driving a speaker for that amplified, filtered amplified signal. Okay. So again, just an example showing that how a digital signal processing system will look like. I really like this diagram. It really shows that how a single dimensional analog signal, can be processed by a digital system. So this is the time axis. They're trying to show it in 3D. So this is the time axis, and this is the amplitude. And here, what it's showing, that it's a varying signal, analog signal, 4 cases, and this is the frequency domain. And as you can see, how we can acquire information relating to what frequencies are present in an analog signal. That's what this particular slide is showing. As you can see here, there is only one frequency, so that's why the peak is here. Any frequency, it's a low frequency, that's why it's on the lower side. This is a high frequency compared to this frequency, that's why the peak is here, going in this direction. And this is the highest frequency compared to these two frequencies, that's why its peak is right here. Since this signal contains multiple frequencies, not one frequencies, so it means it might have peaks in this region, which is not shown here, which is fine. And we will discuss in this particular in this course that how an analog signal gets converted into digital, and how we acquire the frequency information contained in that particular signal. So we will be discussing DFT, we'll be discussing the FFT, their historical journey, and in detail how that mathematical formulas basically work. And in our opinion, it's very important to know the basics before having clarity on a particular topic of interest. And mathematics is the key when it comes down to understanding the basics. Okay, let's carry on. So these are the book we'll be following in this course. The information to this book is given into the reference slide right at the end. But some of the topics, just showing it here, what we'll be covering. Discrete time signals, what it means in the systems, part 1, 2. What we mean by the discrete time Fourier transform, what is the Z transform, and we will discuss digital filters, two types, FIR and IIR filters. We will discuss convolution, correlations. So all the topics, the popular topics are relating to digital signal processing, we will discuss. So over here on the right hand side, it shows that we have an input, a non-linear discrete system, and the output, and how we basically, as you can, this is basically x n like right over here like this, and the processing of that digital information and its progression in a particular processing path. And we will go deep down into the details during this course, that how we do that. Okay. So the preliminary course requirements in this course is a successful completion of high school and a decent knowledge of high school, college math and physics, and good to have a basic understanding on programming. So it's highly encouraged that you have done some level of programming in your courses, which will be greatly beneficial in this particular course. So this is the reference what we'll be following. It's not complete by any means. Okay, so thank you, and see you soon.